Welcome to Data for Good. Raise your hand if you've been to Data for Good before. Did anybody raise their hand? These humorous jokes are really hard to do when I can't see anybody. Uh, if this is your first time to Data for Good, I'm going to tell you a little bit about what we are about and what we do. And all right, we have some hand raisers in the Zoom. We'll talk a little bit about what we do and why we are here, and then we'll get to the reason most of you are here tonight is to see Precision.AI and Naomi speak about drones and data and ag. But in the meantime, Data for Good exists to help build data literacy and socially focused organizations. And the second purpose of Data for Good is to contribute positively to the data community in Saskatchewan. And we do that in a few different ways. One, we have these meetups, which you're at right now. And we have people that come and generously donate their time and knowledge and wisdom for us or to us. And we basically bring people in the data community together. And we do that about once a month. The second thing we do is we have data ambassadors. And those are people who work on data projects for charities and nonprofits, where the charity and the nonprofit is more, is more junior in their data sophistication. So, maybe they're tracking all their data in a single Excel spreadsheet, or, maybe they don't have the storage systems or the dashboarding capabilities figured out yet. And then we have data challenges and competitions and actually larger projects we work on. And I'll get into those here in a second. Oh, right now. So one of those bigger projects is the Regina Food Bank. And right now we have about 20 plus volunteers working on a project for the food bank that involves a whole bunch of really cool things, such as building dashboards, doing forecasting, working in GIS. We're doing a bunch of really neat stuff with their web analytics. So, the Regina Food Bank already has an existing amount of data. And so our Data for Good community volunteers to help them make sense of the data so they can make better business decisions. And coming up now, we have launching tomorrow is our Data Viz Challenge number 2, and which is sponsored by Sask Polytech. And to talk about the Data Viz Challenge, we're going to have Mr. Scott Wells, who's a co-lead here at Data for Good, chat about what that is.
Sure, sounds good. Good evening, everyone. So hot off the first Data Viz Challenge that happened just around the new year, we are launching our second Data Viz Challenge. Based on the feedback that we had from the first one, we've made a few tweaks and a few changes. And as Kevin noted, this one is somewhat sponsored by SAS Polytech. So we're pretty excited about that as well. So in terms of Data Visualization Challenge, and Kevin, you can flip to the next slide there. So what is it? And really what we're trying to do is gain a little bit of expertise for a number of folks in the data community and give them a chance to show off what they're doing. So really it's to take a data set, and we have a data set this time for everyone to use, and really to tell a story with it and show off what you can do in kind of whatever tool you have, and you can build your portfolio. And so what makes a good visualization? And one, it's simple and easy to follow. The second piece, it actually tells a story. And so you're going from kind of a question or a comment that you want to work towards, and then what does it show? What are you doing with it? It isn't just to tell everything and anything about that data or data set. It's to really drive your point home. And lastly, make it as visually appealing as possible. And so there's a couple of examples we're going to show here. And we're not going to go to them in detail, but really just to kind of explain it. And this one I think is super cool. And obviously this is, someone that's an expert in data visualization, but they essentially took all of the records that the Beatles made. And in this one visual, you can actually tell a number of different things, how many top songs that they had on that record, who actually wrote the songs on that record, and over the years. And so they've taken a lot of different pieces, put it into one easily consumable visual. And this is actually one that you can find on Tableau Public. And so most of the visualization tools have somewhere that you can go and actually see what other folks have done. And so that's kind of one good place to look at it. The next visual is really around something a little bit more simple, and it's just around movie theaters and kind of what's happening with them or what happened with them, I guess, last year. This is a little bit dated now, but probably still the same. And so really it's just showing a couple of different things. It's got some words in here, some text to kind of explain it as well, but it's really to show what's happened. And so nothing, flashy or crazy. It's really just around showing kind of that one piece of information of what's happening to patrons to movie theaters. Okay, jumping into the rules next in terms of what's going to be going on. So thank you to SGI and Jose. I'm not sure if Jose's on, but he was able to help get a data set for us. So SGI has provided a data set around bike accidents in Regina from 2010 to 2019. So that'll be the base data set that everyone gets to use. You're allowed to use any other data sets that you want to connect to it, but it's not necessary to do that. So don't feel like you have to. And you can use any data visualization tool that you want. So if you're a Power BI user, if you're a Tableau user, if you're a Click user, go ahead and use all of them. If you want to use Excel, that's completely fine too. However you want to do that. The submissions themselves will go through, will be sent via email and in PDF. We do this just to kind of review them ahead of time, and then folks will be able to show them off for the ones that are selected to kind of the next meetup after this closes. Lastly, you can work individually or part of a team. And so for some folks that maybe are a little bit more junior that want some experts to help them out, you can join a team. And so if you know some other folks, you can join with them. Or if you'd like us to pair you up, you can reach out to us and we will do that. Okay, and then just a couple other pieces of information. So in order to enter the contest, you would actually email Regina at dataforgood.ca. And in there, you can let us know if you want to be solo or placed on a team. If you do want to be placed on a team, let us know what kind of skills you have, and we try and match you appropriately with other folks. And so you may be someone that uses R or Python, and then we'll try and match you with some of those other folks as well. In terms of actually the judging, we do this at the end. So the meetups are at the end of every month. This one will be a 3-month time frame for this, so we'll be doing it at the end of June. In order to be judged, it'll need to be, your submission will need to be in by June 22nd. And then we would ask the top entries to go through and actually present at that meetup. Should actually say June 29th, end of June. In this deck, we will also share it, but there are some data viz examples there that you can link to and find that out. Look for some other ones as well. All right, now to the even more exciting part about this. If anyone's familiar with Billy Mays, but wait, there's more. So SAS Polytech has stepped up and they're actually offering 3 different courses. So 1 seat for each of these courses to folks that have for this challenge. And so what we're doing is anyone that has pre-enrolled in the Data Viz challenge, you'll be entered to win a seat in one of these courses. And so we'll just make sure that we've got your information. Some of these start as early as the end of April. And so that's why we want to make sure we've got these out ahead of time. But these are fantastic, fantastic Microsoft courses that are the certified courses from a range of things, whether it's data science, databases and data management, or the data analyst, and there's 2 in there.
Thanks, Scott. So we're always looking for speakers for the meetup. So if you want to, actually, before we get into that, all the details for the Data Viz Challenge will be posted on regina.dataforgood.ca. So you can check the details out there. The Data Viz Challenge does open tomorrow, and we'll be sending out an email in the meetup where the previous slides with all the correct dates will be posted, all the examples, the data sets, everything you need. So that email will be going out tomorrow. And again, the website is regina.dataforgood.ca. For our meetup here, we're always looking for speakers, and we really have had a wide variety of speakers come through Data for Good. We've had the Pivot Legal Society out of Vancouver talk about how they've used data on addiction to lobby policy around safe injection sites in Vancouver. We've had the Rough Riders come in and talk about how they count how many times a quarterback blinks before he throws a football. And we have cool presentations like Naomi from Precision today coming and talking about AI and drones. So if you want to come in and talk about data in any capacity, please shoot us a note and we'd be happy to look at setting you up. We're also looking for volunteers, and so we're looking for somebody to help us lead the data viz challenges that Scott talked about. And so you'd be working with us chapter leads, myself, Scott, and Josh, who are on the call today, to organize and execute the data viz challenges. You don't need to have any proficiency in data, but you can. And same thing with the communications lead. We're looking for somebody to do some of our social media communications, member engagement, email marketing, and some really easy design. So again, data expertise is not required for either of these roles. So please feel free to reach out. If you do want to reach out, you can jump on our meetup page. That's where we send out most of our communications, but you can find us on Twitter and SlideShare. We have a Slack channel for Data for Good YQR, or Data for Good Regina. If you want to be a part of that, just shoot me an email at kevin.hayes@dataforgood.ca, and then follow us on our Instagram account as well at Data for Good YQR. I think that's it. So I'm going to pass the mic over to you, Naomi. But before that happens, there is a chat if you want to ask questions there about the Data Viz Challenge or about Data for Good, or if you want to volunteer. If you go to the regina.dataforgood.ca site, there's volunteer forms listed on there. All of the chapter leads also have our contact information up there if you want to inquire more about Data for Good or how to get involved and all those types of pieces. And that's it for us. So Naomi, the show is yours.
Awesome. Thanks, Kevin. Can everyone hear me? Can you hear me? Thumbs up. Perfect. All right. Well, thanks for joining me here. I just need to share my screen. 1 second. Okay, I can't see you, so can you, I'm hoping you can see my screen. Yeah. Just want to check before I kick off. Kevin, you can see my screen?
Yeah, we can.
Yeah, you're good. You're good.
Perfect. All right. Thanks for having me tonight, and I'm super excited to be here with Data for Good. This is actually my second time presenting with Data for Good. I presented a couple of years ago with a few colleagues who I'm actually seeing online tonight, so I'm really looking forward to it. Yeah, I'm seeing quite a few people who are working with me here at Precision.AI, as well as some colleagues from ISM and colleagues from other data organizations. So thanks for joining. So please turn your volumes up. I have a couple of cool videos to show you tonight. I'm hoping the audio is going to work for you, but yeah. So we're going to kick off here with a little sample of one of our drones in action. Awesome. So as everyone knows, my name is Naomi, and I started here at Precision.AI last summer in August. I'm the Director of Information Systems here. I've been working for 20 years now as a business technology and GIS professional. Luckily finished school when I was 10, so you can turn your audios on if you're laughing at that one. But anyway, I finished my postgraduate degree from COGS out in Nova Scotia. I don't know if I have any other COGS colleagues on the call or not, but finished my postgrad degree in business GIS there, and also studied here in Regina, and my undergrad was in geography. So just to give you a little background here, Dan McCann is our founder and CEO. He's also from Regina, a local Saskatchewan guy. He is certainly a serial entrepreneur. He founded Precision.AI in 2018, and we are now up to 24 employees and approximately 10 contractors. So it's growing rapidly. super exciting organization to be in right now. We are headquartered here in Regina. I'm actually in the cultivator building. I'm sure many of you have driven by it, or maybe you've come here and visited. There's a little cafe called Slice. If you haven't visited, come visit once this new lockdown is over. Yeah, we're just here on College Avenue, and our drone area where we're building all of our drones that I'm going to go through right away, we're also just down on College at the sound stage. So it's exciting times, and we're in a great location here in Regina. We do have employees in Regina, Saskatoon, Edmonton, Calgary. We have some software developers in India who are actually immigrating to Canada soon, and we have a lot of our AI team who are Egyptian, and we have some contractors in Egypt and a couple who have also immigrated here, and mostly in Edmonton is where our AI team lives. So lots of excitement in terms of our team and locations. And yeah, so let's kick off here. Precision.AI's mission, it's to create intelligence that eliminates chemical residue in our food supply to make healthier, safer food for everyone. So pretty exciting and important mission that Precision.AI is working towards. But usually it starts out with a problem. So what is our problem? Whether you're working on a project or within a company itself, there's always a problem. So in this case, our problem essentially is that what the stats are by 2050, I think we're actually even underestimating here. Our total population is projected to grow to almost 10 billion people. And the estimate is that approximately 70% more food will need to be grown in 2050 than it was in 2009. So we have a huge problem at hand in how we're actually going to be changing the way we handle our agriculture worldwide. So we know there's a big chemical problem as we're spraying our chemicals here. We handle just a broadcast spray in Saskatchewan. You've probably driven outside of Regina or Saskatoon and you see those huge sprayer arms. So today we're just spraying literally everywhere on top of all the food and putting chemicals into all of our food as well as the weeds when we're trying to spray our weeds. If we want to feed the world, we definitely need to grow food smarter. Pesticide application in emerging countries is also a problem. So not just here in Canada, you can see by our image here that we are working with interesting conditions all over the globe. So, and overall, working with food production, it's fundamentally changing all around. So consumers are demanding healthier ingredients. A lot of us don't want to be having chemicals in our food. There's definitely commodities that contain trace chemical residues that are being rejected now by global grain buyers. The trend, I guess, is increasing overall. So it's creating a problem for broad acre producers who rely on broadcast application of the chemical for yield production or protection. And there's certainly a new market that's emerging for a premium commodity. So it kind of sits between the conventional farming, which is what, you know, we're buying most of our food at our grocery stores. And then there's the organic farming. So today we have a market where you can either pick one or the other. So what Precision.AI is working on, and you'll see some of the partners coming up, is essentially to create a new commodity and a new area of food with sustainably grown food. So how are we doing that? We will dive into that. We're going to dive into a little further into the chemical spend, just so you can see the numbers. When I joined Precision.AI, I was actually blown away by seeing this. This is the actual annual overspend, estimated overspend on chemical herbicides. So not even what is spent in total, it's actually the overspend. So a typical farm globally, which is approximately 1,500 acres, spends $57,600 on wasted chemical. Domestically here in North America, we're wasting about $12.5 billion in chemical. And globally, we're at $34 billion. So these numbers are pretty astounding, especially since it's chemical that's actually being wasted. So you can see here in this video, this is our traditional broadcast spray. So up to 80% of the spray in the broadcast chemical application is wasted on this bare soil. So 30% of all the input costs for the farmer is also chemicals, which was a huge number for me. I had no idea when I started here that 30% of the input costs for an entire farm and everything they're working on is actually chemicals. So you can see economically as well as environmentally why this is such a great area to be in. So we're going to kick off with the exciting part for me. What is our solution? So we're gonna have your video or your audio on, please. I'm going to actually just show us a little YouTube video, and I'm hoping everyone, Kevin, please let me know if you can't hear it.
I'm
Will
Dan
do.
McCann. I am CEO of Precision.AI.
Naomi?
We're an artificial intelligence and
Yeah. Can't hear it.
You have to switch to YouTube. Yeah, we can hear it. We just can't see it.
Okay, 1 second. Yeah. Thanks for letting me know. Okay, can you see the screen now?
No. Maybe just stop share and reshare again.
Oh, that's too bad. Okay, hold on.
There you go. We
Good
can
old
see it.
technology.
Oh.
Okay. Good now?
No, just reshare.
Okay, sorry, 1 second. We'll start that over. I was hoping we could do that smooth, but nothing like virtual Zoom meetings. Okay. Can you see now?
It's just loading up.
Okay, I will rewind. Good to go?
No, I can't. Oh, there we go. Yeah, we're good to go.
Okay, and audio?
I'm Dan McCann. I am
Yeah, we're good.
CEO of Precision.AI. We're an artificial intelligence and robotics startup that is trying to solve the chemical cost problem for farmers and create healthier food for everybody. A lot of farmers can spend, somewhere in the vicinity of $40 to $50 an acre on chemicals, and most of that is wasted. Using this drone technology, you can actually drop that chemical usage down by about 80 to 90%. A swarm of drones will come out and survey your fields very fast. There's artificial intelligence built in, so the drones actually have cameras and AI and can see what's going on in the field. They're actually capable of differentiating between, let's say, a weed and a crop. And so in real time, it can identify the location of the weeds within about a centimeter level of precision, and then generate a map of the entire field with 1 centimeter precision of where all of those weeds are. So we take that information and we load it into the sprayer. And so the farmer, as they're driving over and spraying their field, instead of spraying everything, the nozzles only turn on when there's a weed in the vicinity. So it saves a considerable amount of chemical. We have a drone sprayer as well that actually has a 12-foot boom on it. It is capable of targeting individual precision weeds. So a drone can be almost twice as fast as the fastest ground sprayer, so you can get the job done faster while saving less chemical and not damaging the crop with big tires. So Saskatchewan is a great place to do agricultural research and development. We're located within a 6-hour drive of something like 65% of the arable land in Canada. And everybody you know is either connected to a farm or has farmed or knows people who farm. So to get that essential feedback needed to make sure that the research and development for agriculture really actually works, it's one of the best places in the world to be in.
We want to work with these companies as they're developing the products, because a lot of times a product is developed without, involving the farmer, the grower. The advantage that we have here is we're working closely with Precision.AI and the rest of the group on the team. We're using real equipment that we use on our farm every day.
Saskatchewan has recently developed a lot of very aggressive programs to actually encourage innovation inside the province. We've been the recipient of funding from Innovation Saskatchewan, who helped get this off the ground at its very early stages when it was very high risk before we even knew if we could get it done. You've got artificial intelligence, you've got spray targeting, you've got things that have never been done before. Mitigating that risk is really, really important. A project like this, the outcomes that can have by really spraying only what needs to be sprayed and nothing else, has a chance to make a fairly dramatic impact both to farmers' bottom lines as well as to the world at large. And that's very exciting.
From an agricultural standpoint and agricultural technology and innovation, it's already been happening a lot in Saskatchewan.
Awesome. So Dan created that video with Innovation Saskatchewan last fall, actually. It was November. And yeah, I think it's such a great story. I'm just gonna, sorry, 1 second, I gotta go back. Here we go. Okay, we're good to go. You guys can see and hear?
Yeah, you're good.
Kevin, we're good. Okay, awesome. Yeah, so that video was filmed last October. I'll talk a little bit about some of the partners that you saw in there. Terry Aberhard is a huge partner of Precision.AI, and you got to see Dan McCann there. So we're going to dive into our products a little bit here. Mostly tonight, we're talking about our product 1, and that is our first product we are actually about to start testing this spring. You heard Dan talk a little bit about being able to spray from the drone. And many of you probably know there's regulations in Canada here that we have not been able to actually sign on yet to be able to spray directly from the drone in a commercial sense. So currently we're working on a product that I'm going to go through with you right now, where we're actually using our drone to be more of a survey system. And we're going to dive into that here. And then it actually dives right into spraying from the existing sprayers. So just to start from the top here, this just gives you a little flow of what our product is, diving a little deeper, but not too deep. So first off, the drone will do a flight of the grower's field. We have our drone and our camera. Our drone is actually what's called these Alta X. You probably noticed in the video, these are very large drones, a lot bigger than the ones that my son is playing with and other kids might be playing with around. These are probably about 4 feet wide. We've also retrofitted the drone with these high-res cameras. We also have LiDAR on the drone, and we also have what we're calling our brain box, and that's where our AI models are living. So in the first section where the drone flies the fields, we have a ground control system, which actually handles the flight planning, the field surveying, and our work orders in terms of where you're going and what you're doing. The AI model specific to the crop that you're going to be working on is deployed in the brain box on the drone. And the camera will then be taking pictures of the actual crop the whole time and processing in real time the images from the ground through the AI models on the brain box. From there, the weed map is actually generated. So the AI model itself will identify the weeds. So you're looking at whether it's a crop or a weed. So all of our AI models, you're thinking of them as a human brain. I know we've got a few AI people on the call right now who can probably explain this a lot better than I am, but our AI model will identify whether it's a weed or a crop. And then the polygons will be attributed to the map actually, and precise coordinates will be added to the weed polygons. So essentially now you have a polygon layer, and your polygon layer will create what's called a prescription map, which is generated. So that weed map generates the polygon data to create this prescription map, and then the polygons will identify which locations to spray. And you can actually create either a shapefile, an XML file generated, and that will actually feed the existing sprayer systems. So I was fortunate enough last fall to actually get to go out to Terry Eberhardt's farm, and the sprayer, he was in there in the video. I got to check it out, and the technology that is in there today, maybe there's some farmers on the call. I was actually blown away. The sprayer drives by itself. You've got a whole software system in there already. So all we have to do is actually upload the shapefile and XML file into the sprayer system, and they're able to actually control the nozzles and turn them off in the areas where you're not going to spray. So this first product, we're estimating to be able to save chemical spray of up to 50%. So you'll be seeing some other numbers that are around the 90+%, but that is with our next product that will actually be spraying from the drone, which will be a lot more precise. But for now, we're actually specifically working with existing sprayers. So just a little more info on our first product here. We're going to be available for pre-launch in 2022. We're actually working right now for this spring. There's a lot of busy people, and I know a few happy people that it snowed last night, because now we have a little bit of extra time to be able to make sure all of our survey systems are going to be ready for the spring testing that's coming up in the next 2 weeks. Overall though, so the advantages from this first product, there's no sprayer modifications required at all in the existing sprayer. So the farmer can just work still with their huge assets that they already have on the farm. We believe right now, and a lot of the testing we're doing this spring will be confirming these percentages, but we're estimating that 50% of the chemical will be saved from the cost side as well as the spray side into the soil. For those egg people on the call, I think I saw Heather on there, who's our new product manager. This is called Green on Brown, which is spraying everything that's growing. So early in the season, pre-emergent, you're actually going to just take our AI model and do what's the AI will actually just target anything green. So it's going to spray anything green. When you get to the next level, which is what we're calling green on green, or what the egg world calls green on green, that is where you're actually, what I showed before there, you're defining the difference between the crop and the weed itself. So far we've created 2 crop models, which is our wheat model and our canola model, and you'll be targeting only the weeds then. So we're going to dive a little further into the AI so I can give you a little more insight into that. And then the other biggest thing, when you think about rural Saskatchewan or rural Alberta, where we're doing our testing, a lot of times you either have very poor or no internet connectivity at all. So we are doing what's called edge computing, and we're working in the field where we don't need to have any internet at all. So this looks familiar from the video. This is actually one of our drones flying and in action from last fall. And this is the sprayer that I actually got to ride in. So just a little visual here of how it's all gonna come together here at Aberhart Farms. And that was Terry Aberhart you saw in the video. I just wanted to show a little bit in the cab here. This is where the mapping comes in and where the shape files and the XML file will come in and where the farmer will actually be able to see what's being sprayed and what's not. So the AI, this is kind of the exciting part. I have another little video in here to show you guys after, but we're gonna dive a little bit into the video. So essentially AI overall is a disruptive technology in many different industries actually. So specifically here in the egg industry, our AI right now, we've actually have created an AI system that's capable of identifying over 24,000 species of plants. So in real time, as you saw, the weed detects, the real-time weed and crop detection can go at speeds of up to 60 kilometers per hour. And then as we discussed a little bit, here's an example. We've got our onboard AI on the drone, and we're able to perform a see and spray on the drone in real time, and it operates 3 times faster than a normal ground sprayer. So I'm going to show you a little video here. Look in the bottom right-hand corner, and you'll be able to actually see what we did here was we created a video to show the drone flying and then what our ground control station is actually seeing. So I'll play this here so you can see. So here's our drone flying, and then in real time, you can see the camera is actually identifying the polygons. Green is showing crop, red is showing weed, and then that is the weed map that we take to create the prescription map to actually go into the sprayer. I'll just show that again for a little quick view if you can see it on the right side. All right, so let's dive into some of the AI and machine learning data flow. Basically, this top section right here, all of our models are being built in Amazon Web Services cloud infrastructure. We have a huge amount of data collection that was taking place last spring of 2020. All of our canola and wheat model data was being collected. So basically last spring, the data was collected. And then since last summer, our AI team has been building the wheat and canola models for the last, I guess, 8 to 9 months. So data is collected, data is stored in the file storage, imported into the data lake. There's a lot of entity matching in the data catalog, and then we get into the whole data labeling side. So one of the areas I haven't talked about, we have a number of contracted agronomists, and we also have some senior agronomists that are actually working directly on Precision.AI's team as well. And so a lot of them are doing the annotation of these images. So this whole section up top here is all of our build that's been going on for the last 9 months in terms of the green on green crops that we're building. So models are trained. Now we're getting into the deployment. So the AI models are now, actually that's what we're working on today, is we're making all the software connectivity so that we have the deployment of the AI models going into our field tests. So April 15th is our date to start testing out our 2 crop models that we have done, as well as the green on brown, which I touched on a little earlier. And once the field tests are coming in, all of that's coming back. And we have what's called this feedback loop tool, which is a tool that's designed internally where we can keep optimizing our models. So that's kind of the loop that's going on here. A lot of our crop models are trained, or our crop models are trained on thousands of images at this time. We keep trying to optimize speed at this moment, but as many of you know who are the AI specialists on the call, it takes time on the first few models, and then it starts to get quicker later on as we build more. So we do have about 20 different crop models that we're building for this specific project, and I'll dive into that in a little bit. So I'm going to show you another video. There's no sound to this video, and it's embedded right in here. This is a good explanation of how our plan is working for the AI for the customer, which is the farmer. So we are currently working on a dial. So it's a sensitivity dial that actually will allow the farmers to have complete control once the software system is embedded. So they'll be able to change the sensitivity from maximum to lower sensitivity level. So as you can see in the video, You can turn the model to maximum coverage, meaning spray everything, or turn it the other way, which is going to actually start spraying nothing. So where in between is the confidence of the actual model that you're going to be able to want to select. So the farmer does have complete control at every moment. This is a tool and a technique that we're working on right now. It's currently in development mode, but we are completely getting there. So there we go. So next section, we're going to talk about the data. I do believe Mr. Hutch is on the call tonight as well. So he is our data, Greg Hutch, for those of you who know Greg, he's our data architect here at Precision.AI. So feel free to pop in anytime here, Greg, if you would like to add anything. So I just wanted to go through some of our fun data stats, and I have a really cool video for all you data nerds out there. And I'm assuming you're all data nerds since you're joining the Data for Good meetup here. So right now our crop images are taken at a 0.5 millimeter resolution, and you're going to get a close visual of that coming up. To give you a little reference, if you go to Google Earth and you start zooming in, I believe the highest level of resolution you get in Google Earth is between 20 and 30 meters. So we're taking images at 0.5 of a millimeter. Drone capture images at an altitude of around 7 meters. That's the height of where the drone is flying. And then it can fly up to 60 kilometers an hour and still be taking the pictures. So this is our max. We are still, this spring, we'll be testing out how fast the drone will be able to actually collect the data, process through the AI. So optimized speed, these are our top numbers here. So capturing the data, so far we've done an estimate, but approximately it's going to be 7.8 terabytes of raw data per quarter section. So we're truly getting into the big data world here at Precision AI. There's just a massive amount of data that's coming in, and it is one of the, I wouldn't say problem, but challenges that we're working through in terms of the size of the information and data that we're bringing in. And approximately 250,000 images are taken per quarter section. So we're capturing 250,000 images, and that's only 160 acres. And you can think about the size of some of the farmers' fields, and I'm sure you know some people who have 10, 15, 17,000 acre fields. And I believe Terry Aberhart's farm is around 17,000 who we're working closely with. So for those in the infrastructure world, we're using Postgres to store our relational data from the fields. The images are stored in a file system on our BrainBox, which is what I showed you a little bit earlier. And then the processing takes place in an Amazon S3 data lake. And then all of that is then accessible to our AI team to start building the models. So already to date, we do have millions of images already collected, and we know this spring we're going to be adding millions of more images. So there's just a ton of data that's coming in, and yeah, it's an exciting time. So I'm going to show you this video, which I think for all of you, I'll say data nerds again out there, I was pretty blown away when I saw this. Our contractor who is working for Precision AI, his name's Kevin Shear, created this video for us, and he's been our main data collector here at Precision AI for the last few years. So just using Google Earth here, we're starting out with the Google Earth imagery, and you can see, there we go. We're in and around Lagenberg, which is near Yorkton, for those of you wondering that location, right near the Manitoba border. As we dive in further here, this is a drone surveyed NDVI layer, the green and the red, so vegetation index. And as we get in further, you can start seeing some of the pictures that have been taken from the drone. And then we're going to get into some of the still images there. So Kevin Shear, he has his own consulting company called SARES, and it's a whole remote sensing company. He's actually a retired RCMP employee who was a forensic identity specialist. So he used to actually check out all the investigation crime scenes using drones. So he's also one of our drone pilots. So as you can see, we keep getting closer and closer into the data, and this is where we're getting into the 0.5 millimeters. So there's one sample of an image. This is kind of the fan favorite here at Precision AI. As you scroll in, you'll get to see a little, wait for it, you can see the wings of a ladybug. This is our fan favorite here. So you can even see, you can count the dots on the ladybug. So it's pretty incredible where we've come with data and how you're actually able to, you know, mesh Google Earth satellite imagery and then further align and orthorectify some of the images that we have, and then further down into our actual still images. So there we go. Okay, so that's our data world. Again, we can ask questions at the end, and I'm used to kind of having questions throughout, so we'll keep going here. But so let's talk about the market a little bit. So Precision.AI right now, we're still working through a lot of how this is going to look. We are in a ton of R&D mode right now, but servicing the customer, we know it will be once per season. So at the start of the growing season, a farmer would input their crop type into the app. They would pay an annual fee for the AI model license. After payment was received, Precision.AI would dynamically provision the optimal AI model for the crop type, soil type, and region that the specific farmer is in. And then from there, the personalized AI model would be automatically downloaded and loaded onto our brain box on site with the drone. So that's a super high level view of how we would service the customer. Essentially what is happening here is we are changing the economics of farming. Excuse me, we know there some of the sprayers out there are between 500,000 and I've even heard up to 800,000 and 900,000. With drones that are now able to be retrofitted and purchased for 25,000. So the economics are changing. It's going to be a journey for sure, but it's times are changing. So how are we different? I would say we are definitely smaller and cheaper versus kind of the large and expensive, some of the AI things that are coming in. The other area is that with these other machineries that are large like that, they're not able to reach markets where there's different altitude, or sorry, different topography. And we're able to actually be able to, with the drone, flying up and down into a lot of these harder to reach places. Some of the secondary markets that we've been diving into too are municipalities. I'm sure you drive around your city and we have different spraying that happens here in at Wascana Lake. As you can see, Parks and Recreation. If you start getting, you imagine being able to actually just spray just the weeds and not the whole area. I always feel sorry for our little ducks at the lake there when they spray the whole grass. Anyway, and then we get into the golf courses. That could potentially be also a secondary market, as well as even households one day. That will definitely be the future if we all have drones flying around the front of our household for a service once a year. So some of the sustainable outcomes, as I mentioned earlier, we are visioning that the reduction in herbicide usage can be up to 93%. And again, that is with our spraying from the drone product in the future. You get the precision spraying coming directly from the drone. This adds up to 1 gallon or 1.3 gallons per acre of less diesel fuel used in the actual sprayers themselves, and an overall reduction of 29 pounds per acre of carbon. So this is a slide of Dan's here. It's definitely reducing the ecological footprint, and a lot of the testing we're doing this spring will actually be able to start, be able to define that those numbers are exactly correct. So diving into our partners a little bit. Our main partner right now is through Protein Industries Canada. Some of you may have seen it in the news, or if you were following it all with Precision.AI. That was from last summer, and that was a lot of the growth that happened here at Precision.AI was working with this PIC project. So within the PIC project itself, it's Precision.AI, a company called Exceed Grain Marketing. We work closely with Derek Squire, who's the president there, as well as Sure Growth, and that's Terry Aberhart. So you saw him in the video earlier. Terry has a couple of companies, so his farmland is actually, basically there's a section of land that Precision.AI is able to go and replant and dig up and replant, and it's all within this PIC project that we're working on. And one other partner we're working with is GIFTS. If there's any of you in Saskatoon or others on the call, I'm sure you have heard of the Global Institute for Food Security. So we're working with Chris Barker, who's the director there. And we have some of the machine learning students that are actually supporting our AI team with the model builds. So this is kind of our ecosystem here that we're working with. Essentially, Exceed Grain Marketing works very closely with the grain contracts and the marketing side and gets into the buyer's world. That's a whole world I'm learning about. It's very exciting. There's a whole traceability side that we are still about to dive into once this new commodity of type of food market would get there. So closer to the end of this project. And I don't think I mentioned this project is going until 2023. So May of 2023. And I'll show you our little product life cycle next. And then you can see Precision.AI, that's where we're doing the technology, the crop protection, input reduction. And then Share Growth, which is Terry Aberhart and his farm and all of his agronomists are helping with the crop planning and servicing the models and working with us on all of the testing and kind of making sure, as he mentioned, they're getting the farmer's perspective. So it's pretty exciting. So just to give you a high level of our product roadmap, everything we've been talking about today mostly has been the AI subscribed ground sprayer. So last year we were figuring out the minimum viable product in terms of the technology side. This year we've been really diving into the AI subscribed ground sprayer, which is everything I just explained to you. 2022, we're actually looking at high clearance sprayer retrofits, which would actually be working with the sprayer nozzles themselves and retrofitting them to actually spray even more precisely from the actual ground sprayers. And then moving on, the PIC project will end for us in May of 2023. And then beyond that, we'll be working on precision drone spraying. And then the future we see is actually spraying as a service. So that's 2024 and beyond. That's the vision. It's pretty exciting. I will show you a couple of cool really rendering or drawings that we have of renderings of the spray as a service. Before we go there, you can't really talk about what you're going to build without thinking about your competition. So Precision.AI's product one, which is what we've been talking about, competitors. We know we have John Deere and Blue River. Many of you have probably heard of them. I know John Deere purchased Blue River, which was an AI company out of the US, I think 2018. So they are working closely in the AI green on green world. Xarvio Bosch, Weedit, Trimble Weed Seeker, Eco Robotics, Green Eye, and Bilberry. So we're still exploring a lot of these, and some of our people on the call here, some of our agronomists and ag tech people, they at Precision.AI, they've definitely been diving further into this. And me being new to the ag world, I'm definitely learning more and more about these competitors. So it's super exciting to see what's going on out there. The last one is our product two competitors. So this is actually spraying from the drone. I had the opportunity to be on a call with the federal government back in January with Dan, where they were talking about the regulations and everything in Canada. There are a few states in the United States that are actually legally allowed to commercially spray from the drone. And then I believe in a couple countries in Europe are also. So Rantizo is one of the competitors here in North America, and then XAG is another in North America. So the near future, as you saw on our product cycle there, this is a rendering, and I would say probably Dan's vision here, where he's been working with some people in terms of the spray as a service in 2024 is where we'd like to get at. Is this would be driving out to the farm, you deploy a swarm of autonomous low-cost drones that can both survey the whole field and then spray for up to 95% efficiency at a fraction of the cost. So if you have a look at this, this always reminds me a little bit of those Barbie camper vans for any girls on the call, or maybe guys who had sisters. This always reminded me of that when I saw this. Only we're way more in the future here. We would have drones that would be parking in here and flying out, spraying as a service, and then coming back in. So it's a full paradigm shift. This approach completely changes the approach from crop protection to actually crop optimization. And it also is creating new economic models. So this is kind of our future vision that we're seeing here. And yeah, so just a little summary to wrap things up. Precision.AI overall, we're retrofitting drones and ground sprayers with AI and computer vision to spray only the weeds and nothing else. We're going to achieve up to 93% reduction in chemical inputs, saving a farmer approximately $36 an acre on herbicide costs each year. Again, for our product one, more around the 50% reduction mark, but in the next 2-3 years, we're looking at the 93% once we start spraying from the drone. So our patent pending approach is an entire order of magnitude less expensive than competing approaches. Some of the other solutions out there are requiring investments of $150,000 to $650,000. And yeah, just justifying the payback for farmer operations is very difficult on some of our smaller farmers out there. And then the savings on the chemical cost can be parlayed into a spray as a service model, where a farmer can outsource their crop protection for less than the cost of the chemical that they were using today. So that was everything I had today. yeah, I would love to open it up for questions and comments. Hopefully I can answer most of your questions and comments. I know I do have a couple of other colleagues on the call from Precision.AI who might be able to support me in that. But yeah, that's it.
Yeah, excellent presentation, Naomi. And yeah, please feel free to unmute yourself. There is I'll kick it off with a question from Adam. He says, he asks, what is the best way to get into this field as a junior machine learning engineer?
Interesting. So are you in school or graduated already, I guess would be kind of, I mean, first off, whether you're graduated or not, this is an awesome way to get involved, is just being with Data for Good actually, and networking with the people here who are at different locations. And I did see Scott offered some of the classes that would be a prize for some of the Data for Good. So I think just networking and getting involved with everyone. We have recently just hired actually a few drone engineers. We did have a posting out for a data specialist here in Regina, which actually we got a lot of machine learning resumes coming in, because understanding the data side and knowing the AI is such a together approach here at Precision.AI. So being able to do both is fantastic. Yeah, I would just say networking, making sure you're going through a lot of the classes, checking out some of the jobs that are on board. I can see a lot of new AI roles are coming up. Yeah.
And with your background and schooling in GIS, that clearly is a asset for you in your current role. Can you talk about a little bit of the career path and learning and schooling that got you to this particular position?
Sure. It's funny, I was actually going to start that with the presentation. I don't think I talked about it, but I keep reminding myself and blown away that 20 years ago when I finished my GIS degree, I had no idea that I would actually be merged with AI. I spent the first probably 10, 12 years in GIS as an analyst. I worked in Toronto and down in the States, and in Calgary, I had my own small business for a little while. And it was always just analyzing data and, you know, really diving into the data and then getting into more like these infographics that you guys were talking about to actually present the information. It wasn't until I got to ISM, I worked there for 4.5 years, where we started marrying a lot of the GIS with the AI. So doing predictive analytics and being able to have the technology that can combine the two. So I actually feel very lucky and grateful that I've kind of taken this path, and I've learned from many of the people who are on this call actually. The whole AI world, you know, that was new for me for sure. So, but just seeing how spatial data is starting to link, and hopefully you got to see that a little bit today. Yeah, understanding, I think the common denominator that I found at ISM and also here at Precision.AI is, even if you're an engineer building the drones, understanding the data that's going into it is key. So whether you're an AI person, a GIS person, data specialist, or on the hardware side, all of us need to understand what's happening with the data. So data is always kind of that common denominator and key factor, which is kind of what's so cool about this Data for Good meetup. But
Cool. Any other questions?
I will jump in. You've obviously built some really, really cool stuff at Precision. What is one of the, or maybe if you've got a couple top of mind, biggest data challenges you ran into while kind of getting this stuff up and going?
well, we're going through that at this moment, absolutely. For sure, it's what I talked about earlier. It's the size of the data and how we're actually processing the data from the field. So if you can imagine, and Greg, I see you're on here, so you can unmute anytime now since you're my data guru on the call. There you are. I told you I was going to pull you in. Anyway, I'll give a high level and then Greg can probably answer it even better. But as you can see, we have that brain box where our drones are out in the field and we're capturing up to 77 terabytes of data. So how are you now getting that from the drone back into the cloud and to be able to process, right? So Greg's been working really closely with our newest technical data specialist who just joined us a couple months ago, as well as some other engineers on our team. So Greg, I'll kind of let you dive in if you don't mind.
Sure. Great presentation, Naomi, and thanks to everyone for the opportunity to to talk about what we're doing. But Naomi was absolutely right. Like some of our biggest challenges are as we get higher and higher resolution images of the plants to differentiate between the crops and weeds, the data gets larger and larger, and we're expanding the spectrum that we're working with too. So we're adding near infrared. So again, the images are getting bigger. We're selecting more images, higher resolution, to do a better job of picking things like the as we get sort of into the monocot plants that are much more demanding to select. The same time too, then we're trying to accelerate how quickly we can go through the field to increase productivity. So we've got more data we're collecting. We're trying to process it more quickly on board because we're in a disconnected scenario. So we've got the onboard compute at the same time, and that's for the analyzing, picking out of the plants, preparing those weed maps. And so that's the challenge we have with the production systems. For data collection, now we're trying to collect much, much more in the way of images. Naomi mentioned about the millions of images we're planning to collect in spring. We need to get that back, turn those into the new AI models, and then be able to bring that back to the field. So moving that data around, we're expecting, probably 150 terabytes in Saskatchewan, 150 terabytes in Alberta, that we need to move as quickly as we can to be able to create those new models. And out of those millions of images, we're trying to select the very best ones for the machine learning models, get those annotated by our expert agronomists, and then turn those into the new crop models that Naomi was talking about. So dealing with the optimization of those great images, those more accurate images, the hyperspectrum stuff, and then being able to analyze that quickly, turn it into the new models, and turn it into a better product for our customers is a constant challenge. I think for the foreseeable future, we'll be trying to optimize, trying to bring more data in, process it more quickly, turn it into better models that increase our performance in the field. I'm sure, Naomi, I probably glossed over some things, but that's what keeps me up at night.
No, that was fantastic. Thanks, Greg. Did that help, Scott, a little bit of, yeah, definitely the size and the movement of the data right now is our biggest challenge, I'd say.
Knowing we just had a presentation from Sean last month from SaskTel, how does 5G change your guys' business model, or does it with higher speed networks?
I'll always be looking for higher, I'll always be looking for higher speed connectivity because of the data we're moving around. So it's all helping. That being said, though, is, when we're trying to move 300 terabytes in spring, there's still lots and lots of challenges. So all of that helps, but it's still a challenge.
Yeah. I mean, even things like we're building our custom software right now that's living on the drone, and even just being able to pull like a Google Earth API. If you're out in the field and the internet connectivity is going to be terrible or none at all or slow, we want our drone pilots to be able to be streaming just some of the base imagery data. So we're actually working through that right now on how we can actually just input some static data that we can actually potentially purchase smaller amounts so that they're living on the drone right now. But if the internet speeds are going to increase and the entire geography of it, that would be fantastic for us. It's definitely, like Greg said, it's a win-win for us for sure.
Dean.
Hey, how's it going? Sorry, this is such an awesome presentation. I'm super blown away by what you're doing. I was curious about if you see any opportunities, like would you be able to pivot at what you're doing right now for finding weeds and use it for any other kind of field management? Have you, like, would you really have to like redesign what you're doing right now to say, like, instead of looking for a weed or a bug, you look for just different productivity on the farm?
It's an awesome question. And that's definitely something that I've had the conversation with Dan about. Basically, the change would be the design of the AI models itself. So all of the hardware and all of the retrofit that we're building with the cameras and the Xavier and the software of how it's put together, that could maintain for sure. It would just be what you're actually identifying with the AI model. So basically the pivot would have to all be in the AI world. Yeah, I don't know if that answers your question or not, but we are constantly looking at, again, we're in this development mode right now for the government that we're doing a lot of this PIC projects, the Protein Industries Canada. So we are heavily focused on what we're delivering for them. So that we always kind of have our PIC vision and then the Precision AI vision. And there's certainly different discussions happening in the Precision AI vision to be able to pivot. Exactly. It's a great question.
Well, I just wanted to jump on that too, because these are data people. The images that we're picking up include so much additional information that we're looking forward to processing. So things like the near infrared also tell us about plant health. So, you know, we're able to start thinking about things like that, more things about what's going on in the field. I'm really interested in doing some time series stuff around not just what we see, but also what we know from previous passes in the field, and using that to do some prediction work. So I think we're at the very beginning of being able to extract value out of this data that we're collecting.
Kevin, Anthony, you have a question there you have in the chat, but do you want to ask it live? Oh,
You're on mute.
Sure. I don't mind. I was just curious if I misunderstood perhaps that the AI models running on the drones are capable of analyzing those images in real time and generating those polygons. Would there be a market, instead of using the drone at the beginning for your phase one, to put the cameras on the front of a traditional sprayer boom? You might need more than one. If you can process those images in real time, you can control the nozzles in a closed loop system, and then you could pick your images off of the sprayer afterwards. You don't worry about those terabytes of data up front before you've done the application. Just a thought.
So I can see Greg smiling, and so am I. That is one of the first questions we kind of asked last fall. And Dan had told us that that's the angle they had looked at in the beginning. But if you imagine your camera on, whether it's a 4x4 or if you're on a sprayer, even though we think Saskatchewan's perfectly flat, it's not. There's bumps happening all the time. So the images that would be getting taken, there's a constant blur in terms of whether you're going up and down. And to be able to actually process those images into the AI model, you're not able to actually do it in an optimized fashion, I guess. Maybe the world, I'm sure some would be able to process, but yeah, that's basically the reason why Dan didn't take that angle. Greg, I'm happy you're still on here, because this is a lot of the stuff Greg's been working with. And if you have further, that's,
Yeah, I know a lot of the earlier imaging systems were just using color spectrum to look forward. So it's a lot simpler than processing images and putting all this other data in place.
Yeah.
Yeah, I think there's certainly some of our competitors are doing exactly that. And we did some early versions with that. One of the things we got from that worked really, really well was getting the sprayer in line with the weeds. Worked really well. But as Naomi talked about, by the time you get enough cameras and devices spread out to capture it all, and you've got these very large sprayers, it's still a really expensive system. So you ended up with a different set of economics than Dan was looking at. So when Naomi was talking about the retrofit sprayer, there's some things we're looking at there about making the sprayer more efficient, still using the drone to do the survey systems. And as Naomi also alluded to, with the camera systems on the edges of the boom, you end up with some really difficult to get the quality of image that you want, as opposed to when you're on a drone and you don't have some of that vibration effect. So there's some engineering things that we're working on there as well.
Oh, cool. Thanks for the information. Background-wise, I'm an electrical engineer, 20-ish years of experience doing control systems for ag electronics. I've been focused on seeding equipment in my history, currently working in a different company. Terry Eberhard is a customer of mine. I build the apps and electronics for his grain cart scale system. And Randy, who I know works for you guys, used to sit beside me too.
Yeah. Awesome.
Great guys.
Yeah.
Good old Saskatchewan. Everything's 1 degree of separation here. I love it.
Small community for ag electronics, that's for sure.
Yeah.
We've got just a few minutes left. Igor, you had your hand up there for a little bit. Do you got a question?
Yeah, I was just wondering, like with like the migration of things going now to edge devices, and especially now with a lot of computer vision being done in camera, how is that going to kind of impact some of these technologies or some of the decisions in this going forward. Reason why is because I'm looking at, say, there's a camera now, it's called the Oak A by OpenCV, which does 3 or 4 use cases at once, which is object detection, image segmentation, and these type of things. So how does that influence now in the technology selections on what you guys decide?
We're getting a little deeper than I'm able to probably answer in terms of the edge computing side of the world. But I mean, the edge computing, that is what we're focused on right now because of the whole internet connectivity rate out in the field. I don't know, Greg, do you have a answer that could help me out here? Because unfortunately, I have a few other people on the team that I need here to be able to answer that and how the technology is being developed there.
Yeah, I'll take a stab at that, and I'll quickly get out of my depth on how the cameras. I naively thought when we started on this, so we'll go buy a camera that does that, we'll put it on the drone and we'll be done. And what we found is to get the resolution we wanted, to do the near infrared, we started getting into some very complicated camera situations that, thank God, we found some people that understand that at a far better level than I do. The other thing we found is on the back of it then, we started collecting an awful lot of data that we now had to pull together and analyze. So it is a challenge about, as we improve our camera technology, dealing with moving that data to the processors to make decisions, to be able to do that quickly. So I am cheering for the people that are in those industries to go faster, because we're right at the edges of what we're able to sort of put on the drones for processor technology and deal with the precision that we need from the cameras. What we're doing for this season, we couldn't have done last year. And I'm really happy, hoping next year is going to be easier. So that's about the depth I can go on that. Is we're right at that edge of what we can optimize on the drone. And we're looking for the people that build these devices to help us out a little.
But you see things like a Jetson Nano that has GPUs and all that, those type of devices, edge devices coming into this space predominantly, things like that.
Yeah, we're mounting GPUs on the drones. That's exactly what we're doing. And then with our disconnected stations, we're now looking at getting 3090s, loaded up there. And, we are able to take advantage of things like V100s in the data centers. So when we get the data back to the data centers to work on next year's models, we can throw lots of processor at it. But when we're out in the field or on the drone, we're right at the edges of what we're able to do. And then trying to make it ruggedized enough as well, because this stuff gets, it takes some jolts while it's out there.
Thank you.
Thanks, Greg.
All right,
That's
I think we have
all I know about cameras.
we have one last question before we wrap up for the evening. And also, Naomi, I don't know if Cody, which, by the way, thank you to our wonderful meetup organizer, Cody Rogers, who's on the call. We do have a Slack channel if you're open to joining that, and anybody here is also welcome to join that, and we could have more questions. Travis, do you want to end us off for this evening?
Sure. Thanks, Naomi. Thanks, Greg, for the presentation and the chat about what your business is doing. It was so great to hear. I'll take it back to the data geek level, since Naomi used that term a couple of times. I'm really curious what your vision is as your product becomes more mature. How will you approach AI model refinement year over year? And do you envision the growers having any kind of direct feedback into improving the models over time?
Yeah, that's an awesome question. So I kind of glazed over it quickly there, but in that data flow in the machine learning visual there, that's exactly what we're doing. So in terms of when you said, well, the farmers had feedback, Terry Aberhart, who is our partner there, he is actually, his company Sure Growth is filled with agronomists and farmers there, and they are actually working super closely with our AI team right now. And we built what's called that feedback loop tool. So if you saw at the beginning of the process there, they're actually building the AI model first, and then the data comes back around and goes through to actually optimize the data, where the agronomists can go in and with their eye, they understand that apparently, which is what I'm learning, a wheat crop looks almost identical to a weed right at the beginning. The only thing that's different is if you zoom way in, you can actually see these smaller hairs. And I'm actually forgetting whether the hairs are on the wheat or the the weed itself. But so these agronomists, which are a lot of them either were farmers or are farmers or are trained, you know, scientists from school, are able to go in and be able to train the models. So we're kind of building our models with like an agronomy with agronomy brains here. And so it's a constant feedback loop that we're building to be able to optimize the models. And today we know some of the crop models are getting into, you know, 85, 88, 90, 95% accuracy. There's another level on top of that in terms of the AI identifying whether or not it was a crop or a weed. But then also once the file goes into the sprayer, how accurate is the spray as well? So there's kind of two angles as well, dealing with the optimization of the AI model, but also the application of the spray. So yeah, there's two parts there. I don't know if that helped answer your question, Travis, but great to hear your voice, by the way. Travis and I we're colleagues for many years here.
Yeah, no, it did answer my question, Naomi. Thank you. I did see that feedback loop there, so that better explains it. But I had a list of about 10 questions and I pared it down to just one. So testament to your presentation there. It's awesome.
Well, you know how to find us, Travis, if you have other questions.
I have some idea, yeah.
Right on. Cool. Well, thanks, Naomi and Precision for taking the time and sharing your story and all the amazing work that you're doing. I know we just barely scratched the surface of what you're doing. So, yeah, thanks for hanging out with us. And for the Data for Good people, join our meetup. Find us on Twitter, Instagram, or shoot me a note if you want to get on Slack. That does it for tonight, and we'll see you guys next time. Our next meetup is at the end of next month, so stay tuned for an announcement of who's coming up. Thank you.
Awesome. Thanks so much, everyone. See ya.
Thank you, Naomi.
Bye.
Thanks a lot.
Bye.
Good presentation.
Thank you. See ya.
Thank you.
Thanks, Kevin. Bye.
Toodles.